All right, PoA. Let's talk about part four, dealing with function notation. And now, there's nothing scary here, guys. There's nothing scary at all, because this is something that we have dealt with up to this point. It's not brand new. It looks weird, but it is not at all unusual. So, just a quick review here. What this actually says is that the function of x is 2x plus 5. In other words, if I push this button x, what's gonna happen, what f is gonna do to it, is multiply by 2 and then add 5. Well, if you think about it in that context, okay, and I'll write that out just so maybe we can have something to look at. So the function f will 1 multiply the x by 2 and then add 5. That's what it's going to do. Like, so when I pick an x value, I'm first going to multiply by 2, then I'm going to add 5. And that's what it says here as well in the equation. So with that being said, if I look at this f of 3, and again, please let's not forget that the function was f of x is equal to 2x plus 5. When I pick this 3 and stick it into the function for x, I'm first going to multiply by 2, and then I'm going to add 5. So in other words, we're basically doing a substitution. So here's what I mean. So if f of x, if I want to pick 3, this will turn into 2 times 3 plus 5. So just like I predicted over here, I'm going to multiply by 2, and then I'm going to add 5. So 3 times 2 is 6. 6 plus 5 is 11. So it becomes a basic substitution problem. It's presented just in this really weird way. Okay, so same thing over here. Again, I'm going to point out that my f of x value is going to be 2x plus 5. So now if I want to push the button of x and actually make that a negative 2, it'll be 2 negative 2 plus 5. Okay? So in other words, again, I'm going to take this input value, multiply by 2, and then add 5. So negative 2 times 2 should be a negative 4. Then I'll add 5 to it, and I'll get a positive 1. Now, this idea that I keep pushing right here actually is extremely important when I'm looking at part C. So consider this. I took this value, if I take this function, and I pick a value for x, I'm going to multiply by 2 and then add 5. It's going in this order. So if I want to undo it, I actually go precisely backwards. I'm going to subtract 5 and then I'm going to divide by 2 because I have to go complete in reverse. Remember the pointing forward, pointing backwards thing? This is totally pointing backwards. So if I pick this number x and multiply it by 2 and then add 5 and I end up at 25, working backwards then, I'll have to take 25, subtract 5, and then I'll have to divide by 2. That's what it means to work backwards. So we could totally map this out. 25 minus 5 will give me 20. 20 divided by 2 will give me 10. And that's ultimately the answer. X in this case is going to equal 10. Let's see this again. First, let's do a quick analysis on the function. If I pick a value for x, what's going to happen? Well, first I'm going to multiply by 5, and I'm going to take that result and I'm going to subtract 4. Which means if I want to go backwards, I'll do that in reverse order. I'll add 4, then I'll divide by 5 because I'm going backwards. But that's for later. Let's go ahead and deal with this rule now. So if I know that f of x is equal to 5x minus 4, and now I want this to find f of negative 1, what that means for me is I'll take 5, and instead of that x, I'll have a negative 1, and I'll subtract off that 4. So again, just like I predicted before, I'm going to multiply by 5, then I'll subtract 4. So negative 1 times 5 will be a negative 5, and then I'll subtract 4 and get a negative 9. Alright, let's keep rocking and rolling here. I know f of x is equal to 5x minus 4, but I want now to replace that x with a 10. So I'll have f times f of 10, excuse me, is equal to 5. Instead of that x, let's rock out that 10, and then subtract off 4. So now to deal with this problem, I first have to subtract 5, or multiply by 5, excuse me. I can do that, it'll give me a 50. And then I need to subtract off 4, just like my problem indicates, that'll be a 46. Okay. So let's think about working backwards here. If I take this number, x, and then I multiply it by 5, and then subtract 4, I'll end up with 56. So if I want to work backwards, going this way, I first have to add 4, and I can do that. It'll give me a 60. Then I have to divide by 5, because that's the opposite of multiplying by 5, and that will give me a 12. So in this case, x has got to equal 12. Okay, so working backwards, not too shabby. Let's do one more. So f of x is equal to 10x minus 2. So f of x is equal to 10x minus 2. So if I want to now replace that x with a 0, I could totally do that. So if I want to know what f of 0 is, I'll keep that 10. I'll replace that x with a 0, and then subtract off 2. We didn't do an analysis like we did before, but certainly we can see it. We have a times 10, then subtract 2. Let's multiply 10 times 0. I'll give us 0. Subtract 2 in our next step. We'll end up with a negative 2. So same thing here. We have that f of x is equal to 10x minus 2. But now we want to replace it with a negative 3. Okay. So we're going to have that f, and instead of the x, we'll push the negative 3 button. And that's going to be equal to 10. Let's put that negative 3 in there. Subtract 2. Okay. Again, our function rule tells us to multiply by 10 and then subtract 2. So let's multiply by 10, we'll get a negative 30. Subtract off 2 more, and get a negative 32. Okay. Let's do some working backwards. So if I take this x value and multiply it by 10, then subtract 2, I end up with 28. So if I want to work backwards, well, that was subtracting 2. So that means I'll add 2, and I'll end up with a 30. And then I'll take one more hop. Instead of multiplying by 10, I'll divide by 10, which will give me a 3. Okay? So in the end, x is going to equal 3. Boom. I'm not going to talk about the bottom one. All right, guys, that's part 4.